NASA's next mission: the future of space exploration. For more than half a century, humanity has looked toward the stars with one question in mind: what comes next? After landing astronauts on the Moon, sending powerful rovers to Mars, and launching telescopes that can see billions of years into the past, NASA is preparing for its most ambitious era yet. These upcoming missions are not just about exploring space, they are about changing the future of human civilization. The next decade could witness permanent bases on the Moon, astronauts traveling farther than ever before, and the first real steps toward making humanity a multi-planetary species. But how close are we to that future? What technologies are making these missions possible? And could one of NASA's next missions become the greatest adventure in human history? Let's explore the incredible journey that is about to begin. For decades, space exploration has represented humanity's endless curiosity. Every successful mission has answered one question while creating dozens of new ones. From the first satellites orbiting Earth to astronauts walking on the Moon, every achievement has pushed science and engineering to new heights. Yet today's missions are very different from those of the past. NASA is no longer focused only on reaching distant destinations. Its new goal is to stay there, build there, and prepare humanity for even greater journeys. The world changed dramatically after the Apollo era. During the late 1960s and early 1970s, the Moon represented the ultimate destination. Apollo astronauts proved that humans could travel beyond Earth, survive in another world, and safely return home. Those missions inspired millions of people across the globe and transformed scientific research forever. But after the final Apollo landing, attention shifted toward Earth orbit. Space stations became laboratories where astronauts learned how the human body adapts to life in space over long periods. Over the following decades, NASA continued expanding humanity's knowledge of the universe. Robotic spacecraft explored every major planet in our solar system. Space telescopes revealed galaxies billions of light years away. Rovers drove across the dusty surface of Mars, discovering evidence that liquid water once flowed across the planet. Each mission brought scientists one step closer to answering one of humanity's oldest questions. Are we alone in the universe? Now NASA stands at the beginning of another historic chapter. Instead of short visits to distant worlds, future missions are designed to establish a lasting human presence beyond Earth. This ambitious vision begins with a return to the Moon, not as a symbolic achievement, but as the foundation for exploring the rest of the solar system. The Moon is much more than Earth's natural satellite. It is becoming humanity's first stepping stone into deep space. Scientists believe the lunar surface contains valuable resources that could support long-term exploration. Ice hidden inside permanently shadowed craters may provide drinking water, breathable oxygen, and even rocket fuel. If astronauts can use these local resources instead of carrying everything from Earth, future missions will become more practical and affordable. This idea forms the heart of NASA's Artemis program. Named after the twin sister of Apollo in Greek mythology, Artemis represents a new generation of exploration. The mission is not simply about planting another flag on the Moon. Instead, it aims to create the infrastructure needed for continuous exploration. Future astronauts could spend weeks or even months conducting scientific experiments, testing advanced equipment, and learning how to survive in harsh extraterrestrial environments. Preparing for such missions requires some of the most advanced technology ever created. Modern spacecraft are dramatically different from those used during the Apollo era. Engineers have developed powerful launch systems capable of carrying heavier payloads into deep space. New spacecraft feature advanced life support systems that recycle air and water, helping astronauts remain healthy during longer journeys. Artificial intelligence assists with navigation, monitoring equipment, and identifying potential problems before they become dangerous. Astronauts themselves undergo years of intensive preparation. They train underwater to simulate reduced gravity, practice emergency procedures inside realistic spacecraft, and spend months learning complex scientific experiments. Every mission demands extraordinary teamwork, precision, and problem-solving skills, because even small mistakes can have serious consequences millions of kilometers from Earth. One of the greatest challenges facing future missions is radiation. Unlike astronauts living aboard the International Space Station, crews traveling to the Moon or Mars leave much of Earth's natural magnetic protection behind. Powerful solar storms and cosmic radiation can damage both spacecraft and human health. Engineers are developing innovative shielding materials, while scientists continue searching for safer methods to protect astronauts during long-duration missions. Another major challenge is communication. As spacecraft travel farther from Earth, signals require more time to travel between mission control and astronauts. A conversation with the Moon experiences only a short delay, but communication with Mars can take many minutes depending on the planet's positions. This means future astronauts must become increasingly independent, making important decisions without immediate assistance from Earth. Despite these challenges, international cooperation has transformed modern space exploration. NASA now works alongside numerous space agencies and commercial companies to develop technologies, share scientific discoveries, and reduce mission costs. Together, they are building an entirely new era where space exploration becomes a global effort rather than the achievement of a single nation. Commercial space companies have also changed the landscape of exploration. Reusable rockets have significantly reduced launch costs, making missions more frequent than ever before. Private companies are designing spacecraft, lunar landers, communication systems, and even concepts for future space habitats. This partnership allows NASA to focus more resources on scientific research while industry develops innovative transportation technologies. Every new mission also generates remarkable benefits here on Earth. Technologies, originally created for space exploration, have improved medical equipment, communication systems, weather forecasting, satellite navigation, and even everyday consumer products. Investments in space science often produce unexpected innovations that improve life for millions of people across the globe. Perhaps the most inspiring aspect of NASA's next mission is what it represents for future generations. Children watching today's launches may become the engineers, scientists, and astronauts who eventually travel to Mars or beyond. Every successful mission reminds humanity that curiosity, determination, and collaboration can overcome challenges that once seemed impossible. Yet the Moon is only the beginning. NASA's long-term vision stretches far beyond lunar exploration. The knowledge gained from living and working on the Moon will prepare astronauts for humanity's greatest expedition, the journey to Mars, but reaching another planet, presents challenges unlike anything humans have faced before. In the next chapter of this documentary, we'll discover how NASA plans to build a permanent human presence on the Moon, construct advanced lunar habitats, test revolutionary technologies, and prepare astronauts for the first historic voyage toward the Red Planet. The dream of returning to the Moon is no longer just about revisiting history. This time, NASA's goal is much more ambitious. Instead of staying for only a few days, astronauts will learn how to live and work on the lunar surface for extended periods. Every experiment, every landing, and every piece of equipment tested on the Moon is designed to prepare humanity for an even greater destination, Mars 1. Of the most important elements of NASA's future plans is the creation of a sustainable lunar presence. Scientists believe the Moon will become humanity's first permanent outpost beyond Earth. Unlike the Apollo missions, where astronauts arrived with everything they needed and quickly returned home, future explorers will rely on advanced technologies to produce water, oxygen, electricity, and even fuel using resources already available on the Moon. The Moon may appear lifeless, but beneath its dusty surface lies enormous scientific potential. Over the last 2 decades, multiple missions have discovered evidence of frozen water hidden inside permanently shadowed craters near the lunar poles. These craters never received direct sunlight, allowing ice to survive for billions of years. This discovery completely changed NASA's long-term strategy. Water is one of the most valuable resources in space. It can be purified for drinking, separated into hydrogen and oxygen for breathable air, and even converted into rocket fuel. Instead of transporting thousands of kilograms of supplies from Earth, future astronauts could use these natural resources to support long-duration missions. This concept, known as in situ resource utilization, could dramatically reduce the cost and complexity of deep space exploration. To support these ambitious goals, NASA is developing advanced lunar habitats capable of protecting astronauts from the Moon's harsh environment. Temperatures on the lunar surface can swing from more than 120 degrees Celsius during the day to below minus 170 degrees Celsius at night. Without Earth's atmosphere, astronauts are also exposed to dangerous cosmic radiation and constant impacts from tiny meteorites. Future habitats must be far more than simple shelters. Engineers are designing living spaces equipped with sleeping quarters, laboratories, medical stations, communication systems, kitchens, exercise equipment, and recycling technology that can reuse water and air with incredible efficiency. Every kilogram launched from Earth is precious, making self-sufficiency essential. Scientists are also exploring the possibility of building structures directly on the Moon. Instead of transporting construction materials from Earth, robotic systems may use lunar soil, known as regolith, to create bricks through advanced 3D printing technology. Massive robotic printers could one day build roads, landing pads, storage facilities, and protective walls before astronauts even arrive. Another key part of NASA's strategy is the Lunar Gateway, a small space station that will orbit the Moon. Unlike the International Space Station, which circles Earth every 90 minutes, the Gateway will travel in a unique orbit that allows spacecraft to reach multiple landing sites across the lunar surface. This station will serve as a transportation hub, scientific laboratory, and temporary home for astronauts preparing for lunar missions. The Gateway will also provide valuable experience for future Mars expeditions. Engineers will study how astronauts perform during extended stays far from Earth, while testing life support systems, power generation, and deep space communication technologies. Every lesson learned around the Moon will help reduce the risks of much longer journeys. Transportation between Earth, the Gateway, and the lunar surface requires entirely new spacecraft. NASA's Orion spacecraft has been designed specifically for missions beyond low Earth orbit. Unlike earlier capsules, Orion includes advanced navigation systems, improved radiation protection, modern life support equipment, and greater living space for astronauts during long-duration missions. Powering these missions requires one of the most powerful rockets ever built. NASA's Heavy Lift Launch System is capable of carrying astronauts, spacecraft, scientific equipment, and cargo far beyond Earth's orbit. Each launch represents years of engineering, testing, and international collaboration, demonstrating how far modern space technology has advanced. Robotics will play an equally important role. Before astronauts arrive, autonomous robots will explore landing sites, transport cargo, construct infrastructure, inspect equipment, and assist with maintenance. Some robots may resemble wheeled vehicles, while others could walk on multiple legs or even fly using innovative propulsion systems adapted for the Moon's low gravity. Artificial intelligence is becoming another essential tool for future exploration. AI-powered systems can monitor spacecraft health, predict equipment failures, optimize energy consumption, and assist astronauts with scientific research. As missions travel farther from Earth, intelligent software will help crews solve problems without waiting for instructions from mission control. Energy production remains one of the greatest engineering challenges. Since the lunar night lasts about 14 Earth days, traditional solar panels cannot provide continuous power. NASA is researching advanced energy solutions, including highly efficient batteries, fuel cells, and compact nuclear power systems capable of supplying electricity throughout long periods of darkness. Communication networks are also evolving. Future lunar missions will rely on satellites orbiting the Moon to provide continuous contact with astronauts, robotic explorers, and scientific instruments. High-speed communication will allow researchers on Earth to receive valuable scientific data while supporting astronauts working hundreds of thousands of kilometers away. Medical technology is another critical area of development. Doctors cannot quickly reach astronauts living on the Moon, making advanced healthcare systems essential. Future crews may use portable diagnostic devices, robotic surgical assistants, AI-powered medical analysis, and even 3D printers capable of producing medical tools or replacement parts during emergencies. Daily life on the Moon will differ dramatically from life on Earth. Astronauts will wake inside pressurized habitats, monitor environmental systems, conduct scientific experiments, maintain equipment, and venture outside wearing advanced spacesuits designed for long-duration exploration. Every activity will follow carefully planned procedures to maximize safety and efficiency. One of the most exciting scientific objectives involves studying the Moon itself. Researchers hope to unlock secrets about the formation of Earth, the history of the solar system, and the evolution of planetary surfaces. Rock samples collected during future missions could answer questions that have remained unsolved for decades. Astronomers are equally excited because the far side of the moon offers one of the quietest environments for radio astronomy in the solar system. Shielded from Earth's radio interference, future observatories could study the earliest moments of the universe with unprecedented precision. Yet despite all these remarkable achievements, NASA views the moon as preparation rather than the final destination. Every habitat built, every robotic system tested, every life support technology perfected, and every astronaut trained brings humanity one step closer to the ultimate goal: sending humans safely to Mars. The journey to Mars will be unlike anything attempted before. Astronauts will travel for months through deep space, survive on another planet, and eventually return home after completing one of the greatest expeditions in human history. But such a mission demands extraordinary planning, revolutionary technology, and incredible courage. In the next chapter of this documentary, we will follow NASA's roadmap to Mars, explore the spacecraft that could carry humans across millions of kilometers, examine the challenges of surviving on the Red Planet, and discover how this historic mission could forever change humanity's future among the stars.